So in this video, we're going to be working with finding all the zeros of a polynomial, right? Zeros or roots or x-intercept, right? So it's exactly the same. So now I have this function f of x equals x to the fourth plus 8x squared plus 15, right? So first of all, because I'm finding the zero, I'm going to rewrite it as 4x to the fourth plus 8x squared plus 15 equal to 0, right? First thing that I'm going to check if I can factor like a quadratic term, right? So right here, I can rewrite this one because this is x squared. Let's find any other variable. So let's say that a equals to x squared, right? So if I substitute a here, I have a squared plus 8a plus 15 equals to 0. When can I do this, right? First of all, if my first term is even and my second term right here is half of that term, so 2 is half of 4, and I have a trinomial, I can rewrite it as a quadratic term. Now I can factor, right? Two numbers that you multiply and give you 15, and you add and give you 8 are 5 and 3. Now that I've factored that, I'm going to substitute back in that x squared. So x squared plus 5 times x squared plus 3 equals 0, right? Now I'm going to split this. X squared plus 5 equals 0, and x squared plus 3 equals 0, right? So now, because I have a quadratic term and a constant term, I can just solve it using the property of the square root. So now I can take the square root on both sides. So x equals plus or minus I square root of 5 and minus 3 here. So x squared equals negative 3, and the square root of both sides. So x equals plus or minus I square root of 3. So there I have my 4 answers. Okay, so this one again, I'm going to start by rewriting x cubed minus 1 equals 0. So we have a difference of cubes. So this is I'm going to write my x minus 1 times the first one squared, so x squared, plus the second one times the first one, so x times 1 is x, plus the second one squared, so 1 squared is 1, equals to 0. So x minus 1 equals 0, x equals to 1. And x squared plus x plus 1 equals 0. This one, I'm going to have to use the quadratic formula here. So a equals 1, b equals 1, c equals 1. And remember that the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So x equals the opposite of b, so negative 1 plus or minus 1 squared minus 4 times 1 times 1 divided by 2 times 1. So x equals negative 1 plus or minus 1 minus 4 divided by 2. So x equals negative 1 plus or minus the square root of negative 3 divided by 2. So x equals negative 1 plus or minus I square root of 3 divided by 2. So I have my answers there. How many answers should you have? It depends on my degree. So my degree is telling me how many answers we have. So this is a 3, so that means that I have 1. 2 with negative 1 plus I square root of 3 divided by 2. And the third one is negative 1 minus I square root of 3 divided by 2. Now let's see this one. Anytime we have 4 terms, we should start checking if we can solve it by grouping, right? So in this case, I have 6, so that means that I should have at the end 6 answers. Not necessarily unique, but we can work from there. So I'm going to start by grouping my first 2 terms and my second 2 terms. And I'm going to see if I can factor out, so I can factor it again. If not, we're going to see later on some other methods to solve it. So x6 minus x4, my common factor there is 8 to the fourth, so x squared minus 1. My common factor in my second group is negative 16, so I have x squared minus 1 equals 0. When you factoring by grouping, and this sign, so the second sign on the group is negative. I'm factoring out a negative right there. So now I can factor out the x squared minus 1, x to the fourth minus 16. Right? So I have x squared minus 1 equals 0, x to the fourth minus 16 equals 0. This one, I can solve it with the property of the square root, so x equals plus or minus 1. Anything else that is not 2, I cannot use that. So this one I have to factor. But I can factor as a difference of squares. So x squared minus 4 times x squared plus 4 equals to 0. Right? So x squared minus 4 equals 0. X squared plus 4 equals 0. So plus 4 on both sides. So x squared equals 4. And the square root. So x equals plus or minus 2. And now minus 4. So x squared equals negative 4. And the square root of those sides, so x equals plus or minus 2. How many roots do I have? I need 6 zeros. I have 1, 2, 3, and 4, 5, and 6. So the next one. Again, my first step, anytime that I have any trinomial, I did it for the first 3 mentally, but on this one we are going to show it, is to check if we have a common factor. Right? So right here I have a common factor of x. So I have x times x to the fourth over x cubed minus 27 equals 0. Right? Now, so we have x times x cubed minus 3 cubed equals 0. Again, I have a difference of cubes. So x minus 3 times the first one square plus the first one times the second one, so 3x, plus the second one square, so 3 squared is 9 equals 0. Now, I'm going to split all that in 3 factors. So x equals 0, x minus 3 equals 0, and x squared plus 3x plus 9 equals 0. So from here I have that x equals 3. So I have 1 0 here, I have 2 0 here, and I'm just using the quadratic formula here. So a equals 1, b equals 3, c equals 9. So x equals the opposite of b, plus or minus b squared minus 4 times 1 times 9 divided by 2 times 1. So x equals negative 3 plus or minus 9 minus 36 divided by 2. So x equals negative 3 plus or minus the square root of negative 27 divided by 2. 27 I can write as 3 plus or minus the square root of negative 9 times 3 divided by 2. So x equals negative 3 plus or minus the square root of negative 9 is 3i square root of 3 divided by 2. Now, number 5 equals 1 minus 1 equals 0. Right? So this one, I'm going to start by writing it as a difference of square, right? Because I can write this one as x cubed square minus 1 equals 0. So I have a difference of square. So I have x cubed minus 1 times x cubed plus 1 equals to 0. Now here I have x cubed minus 1 equals 0. And I have that right over here, so I can have a little more space, plus 1 equals 0. So I have a difference of perfect cubes, and I have a sum of perfect cubes. So I can rewrite this one as x minus 1, so the first one square, plus the first one times the second one, so x times 1 is x, plus the second one square equals 0. Here I have x plus 1 times the first one square, minus the first one times the second one, so x minus x, plus the second one square, so 1 equals 0. So x minus 1 equals 0, x equals 1, x squared plus x plus 1 equals 0, right? So right now, again, I have to use my quadratic formula. So x equals the opposite of b plus or minus b squared minus 4 times a times c divided by 2 times a. So x equals -1 plus or minus the square root of 1 minus 4 divided by 2. So x equals -1 plus or minus the square root of -3 divided by 2. So x equals -1 plus or minus I square root of 3 divided by 2. Now here I have x plus 1. Let me write it over here so I can have more space. Equals 0. So x equals -1. And so I have 1 0 here, 1 0 here. I have 2 zeros here. Now I'm taking the x squared minus x plus 1 equals 0. Again, a equals 1, b equals 1, -1, -1, and c equals 1. So x equals opposite of b, so 1 plus or minus the square root of -1 squared minus 4 times 1 times 1 divided by 2 times 1. So x equals 1 plus or minus 1 minus 4 divided by 2. So x equals 1 plus or minus the square root of -3. So x equals 1 plus or minus I square root of 3 divided by 2. And I have 1, 2, 3, and 4, 5, and 6. 0. And that's it for this lesson. May the force be with you.